these are recursive routines. So let's just talk about what it says. Susan's grandmother gave her $34 for her birthday. Instead of spending the money, she decided to save the $34. Each week, Susan plans to save an additional $2.50. So if we were going to fill in this table, we're going to use our calculator to do it. But if we were going to fill in this table, we're going to start at the beginning, which would be before a week has even passed, 0. At week 0, her grandmother had given her $34, and that's where we started. So now I'm going to show you how you do this on your calculator, and that's what we're going to write down so that you have record of that you can use later in order to do the same thing on your calculator. So if you don't have your calculator, I'll go ahead and get it. On your calculator, you are going to use the curly braces. I bet you've never used those on your calculator before. You're going to put in a 0 to represent where we're beginning, a comma, and a 34, and then you have to close the curly braces because a lot like parentheses, you have to have an opening and a closing. So if you don't know where they are, they're right above your parentheses. Let me clear all this out. So right above the parentheses, but they're blue. So you hit second in parentheses, and it puts the curly brace. 0, then comma, which is right next to the x squared button, or right above the 7, 34, and then curly brace. And then go ahead and hit enter, and it's just going to write it down again. You are just telling your calculator, I'm about to do a recursive routine, 0 and 34 is where I'm going to start. Okay, so that's all you just did. Now, tell me, if you read this situation, every week, Susan plans to save an additional $2.50. So every week, the 0 is going to go from 0 to what?
250.
Well, hold on. The 0 is going to go from 0 to 1, because that represents weeks. I started at 0, and then I'm going to go to 1, and then I'm going to go to 2, and then so every week I'm doing what?
Increasing.
By.
2.5.
Wait a minute.
By 1.
Thank you. Every week I'm increasing by 1. 0, 1, 2. That's increasing by 1, right? So you take the week before it, and what do you do to it? Add 1. Okay. You add 1. So that's what we're going to tell our calculator to do. So you're going to do curly brace. I'm going to tell my calculator not to take the 0 and add 1, but to take the answer that I've already put in. So I'm going to use the ANS, which is, if you hit blue and negative sign, down here at the bottom. So I hit second, oops, sorry, I have to put my curly brace in. Second and negative sign. Hold on, I can get my act together. And it puts in the word ANS, but my calculator currently has 2 answers in there. The 0 and the 34. So I have to tell my calculator which answer I'm talking about. I'm talking about the first one. So I put parentheses, 1, parentheses. That's just telling your calculator I'm talking about the 0. What did we say we were going to do to the 0? Add 1. So I'm going to write that down so that I have it to remember. Plus 1. Comma. Now, what am I doing to the 34 each week? Adding 2.5. So I'm going to do the same thing in my calculator, but I'm going to tell it to add to the second answer $2.50. So I'm going to plug that in my calculator. Second, negative sign, that pulls up answer, parentheses 2, plus 2.5, and I have to close my curly brackets, they're called braces, and hit enter. And look there, it just did it for you. Now I know you could have done that in your head, but if you'll look down at week 21, at number 8, it tells me to do 21. Now I know you could have just done 34 plus 250 plus 250 plus 250 plus 250, but you would have had to keep track in your head. 1, 2, 3, 4, 5, and 21 is too many to go on one screen. So it would have gone off the screen, you would have lost count, not know where you were, scrolled back, counted them again. In this case, with recursive routines, your calculator is counting the weeks for you. So watch this. Voila! I'm just hitting enter. I put it in. You only have to type it once, then every time you hit enter, it automatically just does it again. Okay, so now I can put in my table. I know it was at 0, 34, gonna have to back up because I hit enter too many times. Back up to 136.50. Now the reason this is called a recursive routine is because the way we are getting our answer is by adding to the line above it. So I started with 34, I added 250, I added 250, I added 250. That's called recursivity, when you just use the answer before it and add something to it. You've gotten way past that in Algebra 1 when you start to do linear functions, but recursiveness is the first idea you start to understand, like when you're back in elementary school, 5th, 6th grade. It's real easy for you to fill in a table by adding to the line above it. And that's what recursiveness is. Now, it's how we generate sequences in series, which is why it goes into pre-cal. Sounds like a real easy idea to be an idea that was in pre-cal, but it was because of sequences in series. Okay, so now we need to graph this. Notice our graph is not scaled for us. That's because they want you to scale it. You got to figure it out. I'll say this. We are talking money and weeks, which means, do you need any negative numbers? No. Now, money can theoretically go negative, but in this case, she's saving money, so her money should never go negative, and time never ever goes negative. So this whole thing should represent quadrant 1. Okay, so when you're scaling this whole thing, we're just doing the L quadrant, just quadrant 1. Obviously, the origin is 0, 0. I can scale my x-axis real easy because that's time. Week 1, 2, 3, 4, 5, 6, 7. Now, scaling my y-axis. How should I scale this?
Tens.
I agree. I think 10s are good. Because we're starting at 34, and from there I'm going up. So I'm going to start with 10s. Obviously, you can't be perfect on this because we don't have the great grid lines and all that stuff, but it looks roughly like that. Now, I did not connect the dots. Why not?
Because it's
not discrete.
It's discrete, and the reason it's discrete is because she saves $2.50 one time a week. So let's say she goes to the bank on Friday when she gets her allowance, and she puts $2.50 in every Friday. So if you looked at this graph as representing a week, you can imagine there's Monday, Tuesday, Wednesday, Thursday in between there, Friday, Saturday, in between those lines, but she does not make a deposit on those days. She only makes a deposit on Friday. So this is the first Friday, this is the second Friday. Does that make sense? So that's why it's discrete. Okay, what operation did I repeat in my recursive routine up here? What did I repeat? What mathematical operation? There's 4 of them, add, subtract, multiply, divide. Which one did you use? Repeated addition. And what does that make my graph look like?
Linear.
It's a linear, and which direction is it headed?
Positive.
Positive, or it's increasing. So I've got an increasing linear graph. All right, then it starts asking me some questions about the weeks. Week 12. $64. Week 50. In case you did not know this on your calculator, I need to go back to when she had 5150. You can just arrow up. That was in week 7. If she needs $100, how long does she need to save? 27 weeks? After 21 weeks, how much money does Susan have?
$86.50.
I have a different paper, I think.
You're on your back.
No, the wrong side. See, typically when we punch holes in something, they go on the left-hand side of the page. Alright, so now on the back, we have another recursive situation. This time Manuel works all summer and saves $1,092. He is spending $35 a week. I want you to use what you just learned about writing a recursive model and using your calculator, and write a recursive model for Manuel's spending plan. Fill in the table and graph and answer the question. So I gave you a minute or two to do that.
That feels